Welcome to Relearn. What is time? It seems like a simple question. We all experience time every day. We celebrate birthdays, catch trains, and watch clocks tick. It feels as though time flows at the same rate for everyone everywhere. But is that really true? Surprisingly, the answer is no. Our everyday experience tricks us into believing that time is absolute. Yet one of the greatest discoveries in physics is that time depends on the observer's motion. Let's see why. Imagine you are standing exactly in the middle of a moving train, while your friend is standing on the platform watching the train pass by. At the instant you switch on a flashlight, light travels toward both ends of the train. From your point of view, the light reaches the front and the rear of the train at exactly the same time because you are equally far from both ends. But your friend on the platform sees something different. The rear of the train moves toward the light, while the front moves away from it. Since the speed of light is always the same, your friend concludes that the light reaches the rear first and the front later. Both of you are correct. The two observers simply disagree about whether those two events happened at the same time. This remarkable fact is called the relativity of simultaneity. This insight led Albert Einstein to develop the theory of special relativity, showing that space and time are not separate entities but are deeply connected. The only thing that remains the same for every observer is the speed of light in vacuum. Time and distance adjust themselves so that everyone measures the same speed of light. Although this sounds strange, it has been confirmed by many experiments. For example, if two highly accurate atomic clocks are synchronized, one remains on Earth while the other travels in a high-speed aircraft. When they are brought back together, the clocks no longer show the same time. The moving clock has measured slightly less time. The same effect is essential for the GPS in your mobile phone. GPS satellites move at high speeds and are also farther from Earth's gravity. Their clocks tick at a different rate from clocks on Earth. Without correcting for these relativistic effects, GPS positions would drift by several kilometers every day. But why does time behave this way? To understand this, physicists combine space and time into a single four-dimensional structure called spacetime. The distance between two events in spacetime is called the spacetime interval, and it is the same for every observer. ds square is equal to minus c square dt square plus dx square plus dy square plus dz square. Here, t represents time, x, y, and z represent the three dimensions of space, and c is the speed of light. Now consider a clock moving only along the x direction. In the clock's own frame, the clock is at rest, so dx is equal to 0. Therefore, ds square is equal to minus c square dt square, where t is the time measured by the moving clock, also called the proper time. For an observer on the ground, the clock moves with speed v, so dx is equal to v dt. Substituting this into the spacetime interval gives ds square is equal to minus c square dt square plus v square dt square. Since the spacetime interval is the same for every observer, minus c square dt square is equal to minus c square dt square plus v square dt square. Solving this equation gives small t over capital T is equal to gamma is equal to 1 over square root 1 minus v square upon c square. This quantity, called the Lorentz factor, tells us how much moving clocks slow down and how lengths contract. Time is therefore not a universal quantity. Different observers can measure different time intervals, and yet the laws of physics remain exactly the same. Even after more than a century of relativity, one profound question remains unanswered. What is time? A clock does not measure time itself. It simply counts repeating physical processes, such as the oscillation of a quartz crystal or the vibration of atoms. Whether time is a fundamental feature of the universe or an emergent concept arising from deeper laws of nature is still an open question. Perhaps the greatest mystery is not that time flows differently for different observers. Perhaps the greatest mystery is that we still do not know what time really is.